The last thing we're going to do in this lesson is to talk about the law of large numbers. We don't have a learning objective related to the law of large numbers, but I want to mention it here because it's going to help us transition from empirical probabilities to theoretical probabilities. The law of large numbers states that as the number of repetitions of an experiment increases, the relative frequency obtained in the experiment tends to become closer and closer to the theoretical probability. So here we're saying, if you increase the number of repetitions, the number of repetitions increases to infinity, the relative frequency that you find from looking at the experiment is going to get closer and closer to the theoretical probability. Okay, and so let's go ahead and explore this idea by looking at an example. Here we're going to consider the experiment of rolling a fair die. On the first column, we see that the experiment was repeated 10 times, then it was repeated 50 times, then 100 times, then 500 times, and then 1,000 times. We are keeping track of the number of 6 that we roll from those repetitions. For example, when the experiment was repeated 10 times, that is when the die was rolled 10 times, we saw 3 6s. When the experiment was repeated 50 times, we saw 5 6s. When the experiment was repeated 100 times, we saw 15 6s. Here on the third column, we're going to write the relative frequency, which is going to represent the probability of rolling a 6 in each of these scenarios. The relative frequency for a 6 is 3 out of 10 for the first row. The relative frequency for the second row, which is when the experiment is repeated 50 times and we see a 6 showing up 5 times, the relative frequency that we can calculate with this would be 5, the number of times we saw a 6, divided by the number of times the experiment was repeated, which is 50. This is going to be equal to 0.1. For the next row, we have 15 divided by the number of times the experiment was repeated, which is 100. We get 0.15. Okay. Next, imagine the experiment is repeated 500 times and you see a 6 showing up 85 times. Then the relative frequency is 85 out of 500. That is equal to 0.17. Okay. Imagine you roll a die 1,000 times, you get 166 6s. The relative frequency here would be 166 divided by 1,000, which is equal to 0.166. Now, you can do this on your own. Why don't you roll the die 10,000 times and you record how many times you see a 6? This is a joke. I don't want you rolling a die 10,000 times. That is why I'm giving you some values here. I want you to imagine that we did this experiment. Okay, so we're not going to do that. But if you were to do that and you find the frequency, you should see that the frequency is getting closer and closer. And we can see it here on the table. The relative frequency is getting closer and closer and closer to 0.166666666. According to the law of large numbers, as the number of repetitions of an experiment increases, the relative frequency should get closer and closer to the theoretical probability. Now you might be wondering, what is the theoretical probability here? The theoretical probability of rolling a 6 is going to be the number of ways you can roll a 6. How many ways can you roll a 6? The answer is 1. Think about rolling a die. Your outcomes are going to be 1, 2, 3, 4, 5, 6. That's going to be your sample space. How many ways can you roll a 6? There's only one outcome that is a 6 out of all your outcomes. Okay? So you have one way that a 6 can be rolled. Out of how many total outcomes do you have? We have a total of 6 outcomes. Again, the outcomes here are 1, 2, 3, 4, 5, 6. We have a total of 6 outcomes. So the theoretical probability of rolling a 6 would be 1 out of 6. Without having to conduct the experiment, we expect the probability of rolling a 6 to be 1 out of 6, which is equal to 0.1666666. Repeating. And so the idea here is that As the number of repetitions of the experiment increases, the relative frequency, in other words, the empirical probability that we calculate here, is going to approach the theoretical probability. And so the last comment that we're going to make here is that as the repetition of the experiment increases, the relative frequency of rolling a 6 is going to approach 0.1666 repeating. Again, the relative frequency is going to approach the theoretical frequency as the repetition of the experiment increases to infinity.